In this video, I'm going to talk about antiderivatives. It sounds like some kind of arch enemy of calculus, but it's not. It's just an antiderivative is the opposite of a derivative. It means we're going to start going backwards. Big F of x is an antiderivative of little f of x if big F prime of x is little f of x. So what is an antiderivative of f of x equal to 2x? Well, that's obvious. That's x squared, or x squared plus 1, or x squared plus 2, or, oh my goodness, there are a lot of them. So when we want an antiderivative of 2x, we will say x squared plus c. C stands for all those infinitely many constants we can tack on the end. So you already know quite a few antiderivatives. Every formula you already know going forward, just think of it going backwards. What do I mean by that? The derivative of sine is cosine, which means the general antiderivative of cosine x is sine x plus c. Okay, that's a whole lot to say, and you know me, I'm kind of lazy. I don't like saying all that when I don't have to say as much. A nice shorthand for saying the general antiderivative of cosine of x is sine x plus c is to talk about the integral, or the indefinite integral. And that's got that funky S looking thing. You'll find what that is in Calc 2. It stands for S for sum. And we're doing it with the terms of dx. You want to think of those two symbols as parentheses. This tells me to integrate. This tells me with respect to x. When you get into multivariable calculus, that will make a difference. Right now, they're pretty much just parentheses. The integral of cosine x dx is sine x plus c. So let's see what else you know. You know the derivative of tan is secant squared, so the integral of secant squared is tan x plus c. You know the derivative of secant is secant x tan x, so you know that the integral of secant x tan x is secant x plus c. Now you may be asking yourself, Megan, what about all those other ones? What about the ones that are negative? Well, we treat those, it's the same thing, but we don't write it that way. Okay, so I know that the derivative of cosine is negative sine. We don't usually talk about the integral of negative sine when we're doing formulas. We just say the integral of sine and then put the negative on the other side. So I know the derivative of cosine is negative sine, so the integral of sine is negative cosine plus c. The derivative of cotan is negative cosecant squared x, which means the integral of cosecant squared x is negative cotan x plus c. Same thing with cosecant. We know the derivative of cosecant is negative cosecant cotan, so the integral of cosecant cotan is negative cosecant x. I have all of these formulas up on Canvas, so don't feel like you need to write all of this down right now. The derivative of natural log is 1 over x, so the integral of 1 over x is natural log of x plus c. The derivative of e to the x is e to the x, so the integral of e to the x is e to the x plus c. And these are all your inverse trig functions, which I'm not going to read. They're online for you. But we've got all these these three other formulas. You might be asking me why I don't have the integral of negative 1 over the square root of 1 minus x squared. Because we tend not to say arc cosine of that. We go ahead and just say that's negative arc sine. We don't use the arc cosine, arc cotan, or arc cosecant very much. So let's do this. If I've got integral of 2x, what we're going to do is we add 1 to the power and then divide by what we get. Just like when you took the derivative, you pulled the power down and subtracted 1. This time we're going to pull the power up and add 1. But if there's nothing there, we divide by... Sorry, my cat's bothering me. When we have the integral of 2x dx, what you want to do is think about how we go backwards. When we go forward with the power rule, we take the power from the exponent, pull it out front, and then subtract 1 from the exponent. Well, to integrate, add 1 to the power, and instead of multiplying the front, we divide the front. So here we're going to add 1 to the power. The power is 1. Divide by what we get. 1 plus 1 is 2. Divide by 2, but there's already 2 there, so we get just plain x squared plus c. If there wasn't a coefficient there, well, I'd still just add 1 and then divide by what I got. So x squared over 2 plus c. What if the number in front is 4, not a 2 or not a 1? Same thing. Add 1 to the power, divide by what you get. So we get 2x squared plus c. And if the number out front has absolutely nothing to do with the power at all, has no factors involved, same thing. Add 1, divide by what you get. So you get 5x squared over 2 plus c. Here we have the integral of 3x squared. X is squared, so I'm going to add 1 and get a 3, divide by what I get, so that 3 nicely goes up. So I'll get an x cubed plus c. If I just have plain old x squared, I get x cubed over 3 plus c. So our rule of thumb here, or theorem, if you have the integral of x to the n, That will be x to the n plus 1 divided by n plus 1 plus c, as long as n does not equal negative 1. If n equals negative 1, then you're dividing by 0, and that's not cool. What happens is if n is negative 1, you really have x to the negative 1 is 1 over x. And the integral of 1 over x we already know is natural log of x plus c. So if you find yourself dividing by 0, go, that's the natural log one. Go back. Let's play with some grosser powers. If I've got the integral of the square root of x, that's just x to the 1/2. And so then I add 1, divide by what I get. So I add 1, I get 3/2, divide by 3/2. Now that looks like shit. So we don't like 3/2 in the bottom, but dividing by a fraction is the same thing as multiplying by its reciprocal, or its flip. So I'm going to bring the 3/2, flip it, and it'll be 2/3 out front. So I have 2x to the 3/2 over 3 plus c. Let's look at a really gross one. Let's say I've got 3 over the 5th root of x squared. Well, the 3 is just a number. I'm going to kind of scooch it aside. Because the x is on the bottom, that means we're going to have a negative exponent, because the x has to be on top for this power rule to work. You can't have 1 over x to something and then do the power rule. It has to be on top. What else do I know? Fractional powers. The top in the fraction is the power, and the bottom is the root. So this is going to be x to the negative 2/5. So I've got 3x to the negative 2/5. I have to add 1, divide by what I get. So adding 1 to this to a negative 2/5 gives me positive 3/5. And then I divide by 3/5, which is the same thing as multiplying by 5/3. And, oh, that's nice. The 3's cancel. I didn't mean for that to happen. But now I have 5x to the 3/5 plus c. If I want to put it back in that notation over here, remember the top is the power and the bottom is the root. So this becomes 5 times the 5th root of x cubed plus c. So this first day is going to be pretty straightforward with the antiderivatives. Remember your derivative formulas going backwards, and the power rule, add 1, divide by what you get. That's all you have to do.